Imagine encountering a looking glass that, rather than reflecting your visage, unveils the cumulative narrative of existence itself. A reflective surface that doesn't reveal the present moment, but instead captures effulgence that has journeyed for eons across an ever-expanding expanse. What materializes before you is not your current self, but a vestige of what once was. An antiquity preserved within elementary particles of light that commenced their voyage millennia before our terrestrial sphere even coalesced into being. This, in essence, is the profound objective underpinning the James Webb Space Telescope. It transcends the designation of a mere apparatus engineered for augmented visual reach. It is, in fact, a temporal conveyance, meticulously crafted to cast its gaze back towards the nascent chapters of cosmic chronology, to bear witness to the genesis of structure, the ignition of primordial stars, and the coalescence of the initial galactic formations that ascended from profound obscurity. For numerous decades, scientific minds adhered to a particular understanding of this grand narrative. In accordance with the prevailing cosmological model, the universe commenced its existence approximately 13.8 billion years ago, an event designated as the Big Bang. In its immediate aftermath, the fabric of space underwent rapid dilation, temperatures plummeted, and latent energy condensed into constituent particles. These particles, in time, amalgamated to form atoms, predominantly hydrogen and helium, suffusing the nascent cosmos with immense nebulae of gaseous matter. Subsequently, a period known as the Cosmic Dark Ages ensued, an era when the universe contained both matter and radiation, yet remained devoid of stellar bodies. No luminescence pierced the pervasive gloom. Gradually, over the span of countless millennia, gravitational forces initiated the aggregation of matter. Imperceptible initial irregularities amplified, collapsing into dense concentrations that would ultimately ignite the very first stars. From the radiance of these stellar furnaces, the inaugural galaxies would eventually emerge. As per theoretical projections, this evolutionary process was anticipated to be a slow and deliberate one. The earliest galactic formations were expected to be diminutive, unorganized, and irregular in their composition. The development of intricate complexity, defined structure, and systematic order was predicted to require billions of years. The further our observation delved into the spatial abyss, and consequently, the deeper we penetrated into the temporal past, the simpler the universe was expected to appear. However, upon the commencement of its observational endeavors, the James Webb Space Telescope initiated a series of revelations that defied preconceived notions. It directed its attention towards sectors of the celestial sphere that previous instruments had characterized as faint and inconsequential. Where earlier observatories discerned only indistinct smudges, the Webb instrument unveiled intricate detail, structural intricacies concealed within ancient light. Instead of rudimentary, disarranged conglomerations, it uncovered galaxies that appeared significantly more developed than anticipated. Some exhibited distinct rotating disk formations. Others displayed compact, luminous nuclei encircled by orbiting stellar systems. A select few even indicated nascent spiral patterns, architectural arrangements that, according to established theoretical frameworks, should not have manifested so early in the universe's evolutionary trajectory. Initially, the scientific community harbored reservations regarding the veracity of the data. The measurement of astronomical distances frequently relies on redshift, a phenomenon involving the stretching of light waves as the universe expands. Should these measurements have been inaccurate, the perceived age of the galaxies might have been miscalculated. Yet repeated observation after observation corroborated the same conclusion. These celestial entities were demonstrably real. And they existed at an astonishingly early epoch, with some having coalesced mere hundreds of millions of years after the Big Bang. In the grand temporal scale of the cosmos, this represents an astonishingly rapid formation. It is akin to discovering a fully realized metropolis in a locale where only the rudimentary stages of construction should be evident. The surprises did not conclude with this initial discovery. By meticulously analyzing the emitted light from these remote galaxies, scientists were able to ascertain their elemental composition. The findings introduced an additional stratum of enigma. These nascent galaxies already contained substantial quantities of heavier elements, including carbon, oxygen, nitrogen, and even iron. These heavier elements are not products of the Big Bang itself.
They are synthesized within the fiery interiors of stars and subsequently dispersed into the cosmic expanse when those stars meet their demise in cataclysmic stellar explosions. This entire process, creation, nuclear fusion, gravitational collapse, and explosive dispersal, necessitates a considerable duration. And yet, here they were, heavy elements appearing far sooner than theoretical models predicted. This observation strongly suggests that the primordial universe may have been considerably more active and energetic than our previous conceptions allowed. Stars may have formed with unprecedented rapidity, lived brief yet intensely luminous existences, and subsequently detonated in rapid succession. Rather than a slow and steady progression, the early cosmos might have been characterized by a period of violent acceleration.
Even more perplexing is the observed presence of supermassive black holes. These celestial entities, possessing masses millions or even billions of times greater than our Sun, were traditionally believed to grow gradually over immense stretches of cosmic time. However, the Webb telescope has detected evidence of exceptionally massive black holes existing remarkably early in the universe's history. Some appear to have attained colossal sizes far sooner than current theoretical frameworks can adequately explain. To reconcile these anomalies, researchers are actively exploring novel theoretical avenues. One hypothesis posits that certain black holes may have formed directly from dense gravitational regions within the primordial universe, circumventing the need for a protracted accretion process.
Another plausible explanation involves hitherto unknown interactions with dark matter, potentially accelerating their formation and growth. Nevertheless, none of these proposed explanations have yet been definitively confirmed, and it is precisely this state of uncertainty that renders these discoveries so profoundly unsettling. The morphological characteristics of these early galaxies introduce further layers of inquiry. Instead of exhibiting chaotic configurations, many display a surprising degree of organization. Symmetrical arrangements, structured disk-like formations, and coherent shapes are observed at a temporal juncture when the universe was expected to be excessively turbulent for such order to emerge. It is as if an unseen guiding influence orchestrated their development. Dark matter, the enigmatic and invisible substance constituting the vast majority of the universe's mass, may indeed play a more fundamental role than previously understood. Rather than solely serving as a gravitational scaffold, it might actively influence the manner in which matter coalesces and organizes itself, thereby shaping the very architecture of the cosmos long before visible structures achieve complete form. Perhaps, however, one of the most profoundly significant discoveries resides not within the intricate formations of galaxies or the enigmatic nature of black holes, but rather within the realm of chemistry. The Webb telescope has identified complex carbon-based molecules adrift in interstellar space, molecules widely regarded as fundamental precursors for the emergence of life. These compounds are located in regions so exceedingly distant that their emitted light has traversed unfathomable distances, requiring billions of years to reach our observational instruments. This implies that the essential ingredients for life were present throughout the universe at a time predating the formation of planets comparable to our Earth. It suggests that the fundamental chemistry conducive to life is not an exceptional phenomenon, but may in fact be a pervasive element, intricately woven into the very fabric of the cosmos from its inception. The ramifications of these findings are truly staggering. The deeper the Webb telescope peers into the cosmos, the more the universe deviates from our established expectations. Instead of a simplistic linear progression from chaos to order, we are presented with a universe that appears remarkably organized from its surprisingly early stages. Galaxies evolve at an accelerated pace. Structures manifest sooner than anticipated.
complexity arises with an almost improbable swiftness. Each resolution attained invariably gives rise to a fresh set of questions. Every new discovery fundamentally challenges our prior understanding. The James Webb Space Telescope has not merely expanded the limits of our visual perception, it has fundamentally reshaped our comprehension of the universe. It has revealed that the early cosmos was not a tranquil period of gradual inception, but rather a dynamic and potentially tumultuous environment characterized by rapid formation and unexpected structural complexity.
And perhaps the most humbling realization to emerge from these observations is this. Every single photon meticulously captured by the Webb telescope has undertaken an extraordinary journey across the vastness of space. These signals initiated their voyage long before our planet existed, long before life itself emerged, and long before any sentient mind could contemplate the mysteries of the cosmos. Now, after traversing distances that defy imagination, they have arrived, bearing with them the unfolding narrative of a universe that remains replete with profound enigmas. We constructed an instrument to observe the universe with unprecedented depth. However, in doing so, we have uncovered something far more significant. The further we investigate, the more uncertain our established knowledge becomes.
And somewhere, concealed within that ancient luminescence, the definitive story of the universe continues to await our complete understanding.